In this video, I'll show you how to solve the ALEKS problem called identifying the electron added or removed to form an ion from an s or p block atom. Now, in order to solve this problem, you need to understand electron configurations. You need to know how to write electron configurations, and if you don't know how to do that, this problem is going to be really tricky. I suggest you take the time to go back and look up how to do electron configurations. So this problem is asking us to identify the subshell or the orbital of where an electron would be removed or added if that atom was going to be ionized. Let's just start with krypton. We're going to locate that element on the periodic table right there. And we could, if we wanted to, we could start by writing out the electron configuration for krypton, although I don't think that it's completely necessary to write it all the way out. As we can kind of imagine in our head, the electron configuration for krypton is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. If we were going to be removing an electron from krypton, the electron that we would remove would be the last electron that was added as we were writing out the electron configuration, which is this guy right here. This electron, electron number 36, would be the first one to go if we were forming a cation. And this ALEKS question is asking, where is that electron located? Where is it at? Well, it is in the n equals 4 and it is in the p block. So that is going to be a 4p electron. That's the one that gets removed. Now, what if we were going to be adding another electron to form an anion? If there were going to be 37 electrons instead of 36 electrons, where would that next electron go? Right there, 5s. That's the location if we were adding an electron. Let's try this again. For our second element, we have sodium right there. And again, the first question is, from which subshell would that first electron be removed if we were forming a cation? The last electron that we added, that electron number 11, that's going to be the first one that would be removed if it formed a positive ion. This electron is located in 3s. And what about if we added another electron? So instead of having 11 electrons, what if we had 12? If we added another electron, that next electron would also go into 3s. It's not uncommon for these two orbitals to be exactly the same. It's not a requirement, as we saw above here, but it's not uncommon for them to be the same. What about our last one? Helium. Helium, if we're thinking about electron configurations, we like to think about helium as if it is located at the top of column 2A instead of at the top of column 8A. That's why I scratched it out and wrote it over here. Where would be the electron, where would the electron be removed if it was forming a +1 cation? Well, that electron, the last electron that we added, is the first one to be removed, and that last electron is in the 1s orbital, so that's the one that would get removed. Where would we add the next electron, electron number 3? The next electron, electron number 3, would be added in the 2s orbital.